So I could look at a particular example. Let's suppose I'm going to slide down a slide. We'll approximate the slide as being frictionless, and it has a height of, I don't know, let's say 4 meters. Nice tall slide like you might find at a water park. I guess it's a little small for a water park, but very big for a playground. I want to know, what's my speed when I get down to the bottom? Well, momentum isn't going to be useful because I've got a force from outside of me, gravity, and I certainly can't work with trying to figure out the Earth's change in motion. Forces are not terribly useful because this constantly changes its shape. So maybe what I could do is work in terms of energy. So if I assume it's frictionless, then the only force acting on me is gravity and the normal force. Normal force doesn't do any work, and gravity is a conservative force. So I can say that it's conservation of mechanical energy. That means the potential energy at the beginning plus the kinetic energy at the beginning will equal the potential energy at the end plus the kinetic energy again at the end. And I know that y initial equals 4 meters, y final equals 0 meters, v initial equals 0, and v final is what I'm looking for. So I'm going to go ahead and put in formulas for each of these. I'm not going to put in numbers, just formulas. Now this is m, g, and we could make it h or y. Let's just call it y initial. This is 1/2 m v squared. That's got to equal m g y final plus 1/2 m v final squared. Now I'm going to go ahead and put in things that are 0. It's the only number I'm going to put in at this point. But I know that y final is 0, so this whole term is going to be 0. I know that v initial is 0, so this whole term is going to be 0. I don't know the mass, but you'll notice every term, at least every term that remains, has a mass in it. So I can cancel that out of both of them. And that leaves me with g y initial equals 1/2 v final squared. Solving for v final, it's equal to 2g y initial, and we take the square root of the whole thing. So that will be 2 times g is 9.8 times y initial is 4 meters, and I take the square root, inverse square, and I'm going to get 8.85 meters per second. Show that here. 2 1.8 seconds squared times 4 meters. Let's check the units. I've got meters squared. That's going to give me meters. I've got seconds squared. Take the square root, gives me seconds. Bring back my calculator. I got 8.85. So that is 8.85 meters per second. Alright, so we get going pretty fast on that slide. And that allowed us to solve a problem we couldn't have solved with just forces or forces and momentum.